Good morning. Today I will deal topic ionization potential, that is also called ionization energy. So we try to understand what is ionization energy, that is also called ionization potential. As we know, electrons are held with the nucleus through the strong force of attraction. And suppose if we want to remove electron from an atom, so we need energy to overcome the force of attraction between the nucleus to the electron. So that energy which is required to remove electron from atom is known as ionization potential. And after removing electron, atom convert into monopositive charge, or you can say if you remove 2 electrons, it can change into dipositive valent. If you remove 3 electrons from atom or ion, it will change into M3 plus. Suppose M is a metal, stand for a metal or an element. So this energy, what energy is required? The minimum energy, you can say the minimum energy required to remove an electron from an isolated gaseous atom to convert it into monovalent positively charged gaseous ion. That energy is said to be ionization potential, or that is also called ionization energy. It is denoted by I, or it is denoted by IP, or it can also be denoted by IE in short. So we can say that the minimum energy required to remove an electron from neutral isolated gaseous atom to convert into monovalent positively charged gaseous ion, that energy is known as ionization energy. Take an example. Suppose M here stand for a metal or an element. If electron is removed from this gaseous atom, then it changes into M plus. So for removal of this electron required energy, suppose that energy is I1. That is called I1. And it may possible in the second case, another electron is removed from the M plus unipositive cation to change into divalent cation. Here energy required, that is suppose it is I2. In third case, it may be possible we remove from M2 plus one more electron, then the energy required, that energy is called I3. Then after removal of electron, it will change into trivalent cation. So this energy or this process is called progressive ionization potential. So we can after the experimental data, it was seen that I3 is greater than I2 is greater than I1, and this is explained on the basis of effective nuclear charge that you will study in higher classes. I want to clear that I am teaching up to level 10. So this explanation you will get in higher class. This energy, ionization energy, is measured in kilocalories per atom. Now, in the next step, we will see which factors will affect the values of ionization potential. There are many factors. If you see in the higher classes, there are many factors which affects the values of ionization potential. As for example, you can say half field and full field, nuclear charge, screening effect, subcell, size of an atom. But in our syllabus, only two are given. So I'm going to explain that two factors which affect the values of ionization potential. The first factor is atomic size. And second factor is nuclear charge. One example I am going to take and explain how atomic size and nuclear charge affect the value of ionization energy. Take an example of a period element: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then is neon. As we know, in the previous section we have studied, as we go across a period, these all have the same cells, all have two cells, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. But as we go across a period, the force between outermost electron and the nucleus, there is positive charge, the attraction is more. So because of the nuclear charge increases as we go across a period, nuclear charge increases, and because of the more nuclear charge, the force of attraction between the nucleus and the outermost electron is more. If force of attraction is more, as we know, the size will decrease. And if size will decrease, it means there is a more force of attraction. So if we want to remove electron from suppose from the fluorine, there is more force of attraction. So the removal of electron need more energy. And that energy, as we know that energy is called ionization energy. So we can say that as we go across a period, nuclear charge increases, force of attraction between the nucleus and outermost electron is more, therefore atomic size will decrease and ionization potential or ionization energy will be more, because attraction ज़्यादा होने के कारण क्या हो रहा है कि वहाँ से इलेक्ट्रॉन हटाने के लिए आपको ज़्यादा एनर्जी चाहिए, और that energy we said is ionization potential. So as we go across, ionization energy increases. Now we'll talk about group. Take a group element, suppose lithium and potassium. I'm taking only 3. Their configuration is 281. Here is 2881. So as you saw, when we go top to bottom in group, the number of cells increases. So as number of cells increases, the attraction between the outermost electron and the nucleus will be less, because their distance is more. Distance is increasing. As the number of cells increases, means radius increases, atomic size increases. If atomic size increases, it means here the force of attraction will be less. If force of attraction will be less, then this valence electron is easily removed, means we need here less energy as compared to remove this electron, because here size is small in case of lithium, so your attraction is more. If attraction is more, it is very difficult to remove electron. We can't say difficult, but we need more energy. So as you go down in a group, then atomic size increases and IP decreases. So these are the two factors on which ionization potential depends. But here in your book you can see there are many exceptions, and that you have to know what are the exceptions and why they are exception. So I am going to write some exception and try to understand why these are exception. So in your book you can see that the IP of beryllium is greater than boron and magnesium is greater than aluminum. As well as you can see in the 15th group, nitrogen is greater than oxygen and phosphorus is greater than sulfur. What is the reason? Here IP is not following the rule, not following the trends what is in periodic table. Here beryllium should be lesser than boron, but we are seeing here exception. Reason is in your book it is not given, but I am giving here why it is happening. Half filled or full filled orbitals or subcells are nearly more stable. If they are more stable, it means beryllium is more stable than boron. If it is more stable, I am going to explain what is meaning of half filled and full filled. Beryllium atomic number is 4, so it will be 2, 2, and boron is 5, so it is 2 and 3. If you make a orbital, this is S, 1s, this is 2s, this is 1s, and this is 1s, then here 2s, and then will be in P. So in S, 2 electrons can go. You will study in higher class. Again, I am saying this explanation you will get in higher classes. Just for your knowledge, I am giving here in 2s how many electrons? 2. So one clockwise, one anti-clockwise. Here how many electrons? 2 electrons in. Here is 2 and here is 1. You can see that here the outermost cell is fulfilled. S capacity is 2, and how many electrons it has? 2. So it is called fulfilled. But in case of boron, you can see the outermost having 1 electron. This is P. This is P orbital, and here must have 6 electrons. That is called fulfilled. Means each box is having to have 2 electrons, but have only 1. So if it contains 1 electron in each orbital, that is called half shell, or 2 in each orbital, that is called fulfilled orbital. But neither it is following half filled nor following full filled. That's why we can say boron is having less IP as compared to beryllium, because beryllium is fulfilling the condition half filled or full filled orbitals are nearly more stable. So these are the reason. Because of that, these 4 are exceptions in ionization energy values. There are more exceptions you will see in the transition element, but that is not given in our syllabus. So I hope you have understood why they are exception, why beryllium, why magnesium, why nitrogen is having more IP than the 16th group element. Now we will see the last topic. What are the periodic trends for ionization potential? So as we saw in the previous section, when we go across a period, atomic size decreases, and when we go down a group, atomic size increases. And as we go across a period, size decreases, it means IP increases. And as we go down a group, size increases, it means IP decreases. This is called periodic trends. I have given in the short, you can write in word also. It can be written in word. How? You can write across a period, atomic size decreases, as nuclear charge increases, hence IP increases. You can write in that way also, but this is the short format I have given that you can easily memorize. Now one more thing I am going to tell, what are the use of this IP? क्या बेनिफिट है इस आईपी का, हमारे लिए क्यों यूजफुल है, दैट ऑल्सो वी नीड टू नो, इसके बारे में हम लोग पढ़ें तो आखिर इसका यूज़ क्या है, क्यों हम लोग इसको पढ़ें, क्या आखिर इसका यूज़ क्या कर सकते हैं। तो इसका यूज़ ये है, अगर इफ़ द वैल्यूज ऑफ आईपी इज मोर, अगर वैल्यूज ऑफ आईपी क्या हो रहा है, बढ़ रहा है किसी भी एलिमेंट का, तो हम लोग बोलेंगे कि वो एसिडिक नेचर की तरफ जा रहा है, दैट इज शोइंग एसिडिक नेचर. So easily we can say if high value of IP means it's showing acidic nature. If low value of IP, it means it is showing basic nature. Or one more thing you can say, if the IP of an element is low or less, that element will behave as a or act as a reducing agent. And the element who possesses more or high IP, that will act as an oxidizing agent, and we know that what are the use of oxidizing agent and reducing agent. So these are the useful points or important points to know what are the importance of ionization energy or ionization potential. So you must know this topic, and I hope you have understood what I have discussed here. Now I am going to end this topic here. One more thing I want to tell, in whole periodic table, helium He possesses the maximum ionization potential, and Cs cesium is possessing lowest ionization potential in whole periodic table. You must mark it and remember it. As well as one more thing I want to tell, the zero group element means helium, neon, argon, krypton, xenon and radon. These all possesses maximum means in the same period they possesses the highest ionization potential. Maximum is helium, but in the same period inert gas possesses the highest ionization potential. So I am going to, reason is that for what, because they possesses complete octet structure, that's why IP is more, because have fulfill orbital. Now I am going to end the class here, and I hope you have understood. Thank you.